Heavy construction machinery transforms engineering design into physical reality. At site level, these machines are deployed in a precise sequence, each one preparing conditions for the next. Improper utilization leads to delays, cost overruns, safety incidents, and structural defects. Correct utilization converts theoretical design into durable infrastructure. Let's come to discuss how heavy construction machines operate with precision, power, and engineering intelligence. Bulldozers. At construction sites, bulldozers are primarily utilized during initial earthworks. Their role is bulk soil movement, vegetation clearance, and rough leveling. Bulldozers are not finishing machines. Their correct utilization is limited to short pushing distances and controlled slopes. Misuse on steep gradients or saturated soils is a leading cause of rollover accidents. Typical site utilization: clearing and grubbing, cut and fill, balancing, working near embankments and borrow areas. Excavator. Excavators are utilized for excavation, trenching, foundation pits, and loading operations. Their effectiveness depends on correct benching, trench support, and working radius control. At site level, excavators must operate outside collapse zones and maintain safe offset distances from trench edges. Typical site utilization: foundation excavation, utility trenching, loading dump trucks. Motor grader. Motor graders are utilized during subgrade preparation and final surface shaping. Their role is drainage control, camber formation, and level tolerance achievement. Graders must never be used for bulk earth moving. This results in surface irregularities and long-term pavement failure. Typical site utilization: subgrade trimming, base course leveling, drainage slope formation. Wheel loader. Wheel loaders serve as the backbone of material logistics. They are utilized for stockpile management, loading trucks, and feeding batching plants. Excessive bucket loads and high-speed turns compromise stability and productivity. Typical site utilization: aggregate stockpiles, truck loading, plant feeding operations. Cranes. Cranes are utilized for vertical material movement where horizontal transport becomes inefficient. Their site utilization depends on lift planning, wind monitoring, and exclusion zone enforcement. Cranes should never be utilized beyond rated load charts, even briefly. Typical site utilization: structural steel erection, precast element lifting, high-rise material transport. Roller compactor. Rollers are utilized to achieve design density in soil and asphalt layers. Proper utilization requires layer thickness control and correct vibration settings. Typical site utilization, subgrade compaction, base and subbase layers, asphalt compaction. Dump truck. Dump trucks are utilized throughout the construction site for transporting bulk materials efficiently between excavation zones, stockpiles, processing areas, and designated disposal locations. These heavy-duty haulage vehicles play a critical role in maintaining continuous workflow during earth-moving operations, aggregate delivery, and waste material removal across large-scale infrastructure projects. Proper haul road design is essential because it directly impacts operational safety, transportation efficiency, equipment durability, fuel consumption, and overall project productivity. Well-maintained haul routes with adequate width, stable gradients, proper drainage, and controlled traffic movement allow dump trucks to operate safely under heavy loads while minimizing delays and reducing the risk of accidents. On modern construction sites, dump trucks are commonly utilized for earth haulage during excavation activities. Asphalt paver. Pavers are utilized during the final stages of pavement construction to place asphalt layers with high precision and smoothness. Their performance depends on uninterrupted material supply, proper asphalt temperature control, and consistent screed operation. Continuous paving operations are essential for achieving uniform pavement thickness and surface quality. Any interruption during paving can cause surface defects, weak joints, and premature pavement failure. Pavers are commonly used for placing binder courses and final wearing courses on highways. Efficient paver utilization improves pavement durability, ride comfort, and overall construction productivity. Successful projects rely on correct machine utilization sequencing. Each machine prepares the working platform for the next. When utilization is wrong, failures compound rapidly.